Hi guys, welcome to this video lecture. This is Dr. Moorthy working as assistant professor in the Department of Automobile Engineering, SNS College of Technology, Coimbatore. So this is a lecture series of engineering mechanics, and in this lecture series we have discussed about what is engineering mechanics, what is statics and dynamics, and what is free body diagram, and what is equilibrium condition, what is vector representation of forces, and what is our centroid, and these are the concept already we have discussed in the previous videos. And in this lecture video we will discuss about parallel axis theorem and perpendicular axis theorem. So these both parallel and perpendicular axis theorem are used to find what is the moment of inertia of the object, right? So where first we will see what is parallel axis theorem. So the theorem says that the moment of inertia of an area about any axis parallel to its centroidal axis is equal to the moment of inertia about the centroidal axis, and also the product of area of the section and the square root of distance between the two axes. So these two axes are the reference axis and the centroidal axis. So where I is the moment of inertia about any reference point that we want to find the moment of inertia, and ig is the moment of inertia about the centroidal axis, and the area is the area of the particular section. If you take a composite section, so it is the moment of area of the composite section, and d is the distance between two axis from, that is the centroidal axis and the reference axis. And some applications for about the parallel axis theorem. They find the moment of inertia of build up beams like plate grader and T's beams, I sections, composite columns. So this is the practical application we have seen in this screen. It is the beam that parallel axis theorem are used to find the what is the moment of inertia of the composite section, that is include the entire beam over the entire length. And then the right side, the design of columns and compression members, where we can find what is the moment of inertia on the each section. And some other applications like the analysis of thin walled and box section, where the moment of inertia is having, and earthquake and wind load analysis of where the load path for moment of inertia forces is in the resisting frame, that we can able to find what is the inertia force is acting on the object during the earthquake. And also also we can find the wind load analysis. Next one is the another application of for what is the moment of inertia in the application called ship, and for the mariners. And if the ship is moving in the ocean, and we can find what is the moment of inertia and the different direction that we can able to find using the parallel axis theorem. And another one is the perpendicular axis theorem, also used to find the moment of inertia of the section, where we can add the moment of inertia in the horizontal axis and the moment of inertia in the vertical axis. Then the addition of these two, we can get the moment of inertia in the another axis called perpendicular axis. So that is what the theorem says, perpendicular axis theorem. And see, for any plane lamina that may be a thin 2D body, the moment of inertia about an axis perpendicular to the plane, it should be equal to the sum of moment of inertia about another two mutually perpendicular axes lying in the same plane and intersecting at the same point. So if you can take adding the two moment of inertia about two mutually perpendicular axes, that we can get the moment of inertia in the another axis. So, and the various applications with the perpendicular axis theorems are including the moment of inertia calculation, the structural applications, as we have seen in the previous slides. and as like in the beams and columns, and analysis of slabs and plates, and torsional analysis of circular members, design of structural connections and joints, and other applications like bridge, as we seen in the previous slides, we can able to find the what is the moment of inertia in the bridge, maybe with the help of parallel axis theorem, and here we can also find the moment of inertia with help of the perpendicular axis theorem as well, and the earthquake and wind load analysis, geotechnical and foundation analysis with the different applications. And so this is some assessment for us to find the questions called the locus of all the points, the different planes are given, and the moment of inertia along the axis parallel is in the same direction, and what is the O means we can able to find what is the moment of inertia. The answer is circle. Likewise, we have different assessment, then we can able to find with the help of both parallel axis theorem and as well as perpendicular axis theorem. Thank you.